So let's just imagine that you're uploading an ordinary picture and then suddenly you leak backend files. Well, that's exactly what happened to CVE 2022-44268 through the ImageMagick module, and we're going to be taking a look at how to exploit it on the scriptCTF 2025. So this CTF happened last weekend, and there were 2 web challenges. Currently, the CTF is still going on as I record this, but I decided to get at least one of the challenges out now in the meantime. So we're going to be taking a look at the Wizard Gallery challenge, and it says the council's top priority is to protect the flags no matter the cost. Oh, hey, look, it's a photo gallery. What can go wrong? As well as a .zip file as the attachment, and we can go out and launch the instance right now. So as the instance is spinning up, we can head on over to the link and just wget it into our terminal here. And then we could just unzip it and we will retrieve all the files. So going into VS Code, we could take a look at some stuff in the backend that's going on behind the scenes in our instance. To start, there is a Flask application that's running in the background, and we do see that import OS, and we see that the OS module is being used here. And essentially, it's going to a /uploads directory on the backend. We could see that there are allowed and blocked extensions, which will be useful here in a few minutes. If we keep going down, it just checks for allowed and blocked extensions, and it'll return true or false based on whether or not it is valid. We see that there is a wipe upload directory, which will wipe everything within the uploads folder. There's a /endpoint, there's a /logo.png endpoint. There's also a /logo.txt endpoint, which if the file path does not exist, so if there's no logo.txt.png and it doesn't exist, it's going to execute a OS system command, and this is pretty dangerous. Additionally, we have the upload section, and inside of the upload section, which is a key point to this challenge that a lot of people, I guess, didn't see originally, was that there is the wipe upload directory whenever something happens. So if an attack is detected, it's going to wipe all the upload directories and we won't be able to see any more uploads. It's going to erase everything and we'll have to upload everything all over again. In addition to that, you can go over to the API gallery and it's going to show you all the different files that are stored on the system. However, if there is a logo.txt, it's not going to show that within this API either. Something very important to note. And then we could just upload it. And again, if you try to force browse to this logo.txt, it's not going to work through the uploads directory because we already have something set in the /logo.png. Now, something that I want everyone to take a look at is this file structure. We could see here that where the main.py is where the flag.txt is. That means that wherever it's running, we can just simply access it through flag.txt. We're not going to need to try to find a different file path or anything of that nature because the flag.txt is within the same directory as the main.py. Additionally, as you can see, the logo.png is also in the same directory as the main.py. And I'm going to show you why this is important in just a second. But if we go back over here, let's take a quick look a little bit more at the Magick library. So if we go on over to the terminal and we do an ls, we can see that there is a Magick section here. And if we go into Magick, there are a few different areas that we can look at. We can look at the bin, which is just going to have all the different kinds of commands. And there's also the .lib. So if we go to the lib, we can see that it actually gives us the version of this Magick. So ImageMagick 710. If we copy this on over to our browser and we just type Magick exploit 710 and we click on enter, we can see that there are a few vulnerabilities associated with it. One being the CVE 2022-44268, and it's an arbitrary file read. We're going to quickly go on and try to find a GitHub one that has it. So let's just type in GitHub and let's see if anything shows up here. So we'll just click on this one. This one is fine. And essentially all this vulnerability is doing is it is uploading a EXIF data point into a PNG file. And what it's going to do is it's going to place whatever sort of file you want to upload, which in our case, it's going to be file.txt. But if you're on a Linux system, let's say, you can go to etc password and retrieve the etc password information there. So when it converts or does something to the file, let's say it's resizing it, it's going to execute and retrieve the file contents of whatever is within the profile exif data. And then you can go on to decode the hexadecimal values from the raw profile type when you retrieve the file again, and then you will retrieve whatever information we have here. So I know that's a lot to take in, but I'm going to walk through every single step along the way. So we're just going to copy on this source code to our terminal. So let's head back on over to the vids, and we'll do a nano to exploit.py. We'll paste that in. And when we do a Python 3 exploit.py, we can see that there's a few things that we need to do. Number one is we're going to need to access the local file, and then we're going to figure out what we want to output. So we're going to do a Python 3 exploit.py tacf, and we're going to want to get the flag.txt, and we're going to want to output it to logo.png. And what this is going to do is this is going to create a POC PNG through the logo.png. And we can check this by going to ExifTool, and then we can go to logo.png. And we can see here it created a profile exif data point with flag.txt. So again, if we go back to the source code and take a look at where the files are being uploaded on the file system, it's being uploaded to the folder of /uploads. But again, we need to first wipe the uploaded directory. And that's because if we head on over to our instance, so let's go back to scriptCTF and let's copy this here. So if we go to this URL, we can see that we get a nice display, and here is the PNG file. And if we, let's say, just upload, for instance, a logo.png, and we click on cast, we see that it was uploaded successfully. But if you look closely at the URL, we can see that it's actually being uploaded inside of the uploads directory. That's not what we want. And the reason why is because, as we could see within our current process, number one, in the file structure, the logo.png is within the main.py. That's where it's being rendered. That's number one. And number two is if we go down to our endpoint for the logo tag.sm, we can see that it's not going to a specific directory. It's sticking to the logo.png. So it's not going to the upload directory. It's going to stay in the same file structure as what we have here. So in this case, we want to stay within the main.py. That being said, we're going to head back on over to our application. And the first thing that we're going to want to do is we're going to want to delete everything. We don't want any logo.pngs. We don't want any logo tag.sms, because if we go to logo tag.sm right now, we can see that there is the standard logo, which we see right here. It's just created a little bit differently because it's resized. So we can go to browse, and what we could do is, because we know that one of the blocked extensions is a .py, we can simply use the main.py that they provided to us. When we click on enter, it says attack detected, and it says that everything was wiped for security reasons. This is good, because that means that we can now play with the logo.png and the logo tag.sm and try to retrieve data from the backend. So what we're going to want to do is you're going to want to open up Burp Suite, and you're going to want to intercept on, and we're going to choose the logo.png that we just created with the exploit script. So let's copy that, and let's cast upload spell. And as we can see, we get the post request here. Now I'm going to quickly drop it, and you can go on to forward it if you so choose. But I want to show you something pretty interesting. That is, whenever you're dealing with a file system, specifically having to do with Python, you can do a bunch of things. First and foremost, you could do .. and sometimes, depending on how the server is configured, you'll receive error messages. So let's say you were trying to figure out the file system on an actual environment. You can come here, and if it says permission error or permission denied, you can then see exactly where the file system is loading this program. In this case, it would most likely be home, chal, and then main.py, app.py, something along those lines. So this is good for real world experience. If you do see something like this where they are using a Python web server, you can come here, you could try to upload a ffile, and you could try to put a couple .. If it doesn't have permissions, there's a good chance that A, you have LFI, because I'll show you why in just a second. And number 2 is you can then go on to find the file structure where everything is located and then do additional enumeration to the file system on the back end. But that being said, because we have this permission error, what we can do is we can just backspace it to just one directory. So now instead of it going to uploads, it's going to stay inside of the challenge folder. And when we click on send, we could see that it was successfully uploaded. Again, when you do go and just put logo.png, it's going to show inside of the uploads directory. Now, because we've just uploaded a .logo.png, we could head on over to the gallery and see whether or not we see the logo within it. And we'll just come here and we'll forward that and we'll stop intercepting, and we can see that the magical vault is empty. And that's because we moved the logo.png one over. So if we go to now logo.png, we can see that we overwrote the logo.png to be our image. Now what we could do is we can go over to TAC-SM, and when we click enter, we could see that now our image or our logo that we initially did is resized. So if we come here and we copy the image link and we do a wget to this, we now have the logo tacsm.png on our system. We could do an ExifTool on it, and we could take a look at some of the contents. And what you can see here, which is what we saw on our GitHub that we were originally on, it says raw profile type text. Binary data is 64 bytes, and you can use the TAC-B to extract this data. So we're going to go over to ExifTool again, and we're just going to put a TAC-B. And we could see here that we do retrieve information, and we could take this and we can begin doing the Python command to go about decoding this. So the way that you can do this is you can do Python 3, TAC-C, and then you're going to want to do a print. And this is already it, just because I did this beforehand, but you're going to want to do bytes from hex, paste in the hexadecimal value, and then you're going to want to decode it to UTF-8. And when you click on enter, we could see that we do retrieve the flag, which is this, and we're going to have to obviously put potentially the bracket at the end here. So let's click on submit. Oh, and it looks like it's incorrect. So what I think we also have to do is add this at the end of it. So we'll just come over here and we will paste it on in, click on send, and we now have the full flag here. So we gotta add back on over to our challenge, click submit, and that was the correct flag. So Wizard Gallery is done. And that's all for this episode. If you did enjoy, please let me know in the comment section down below, and please like, subscribe, and I'll see you in the next one. Take care.